And these included configurational structure and the location of perspective point, which we dealt with, and attention, distribution of attention, which we didn't really touch on, and force dynamics. So today's two talks are going to be elaborations of the first schematic system, which is configurational structure, in particular how it works out in space. And what I'm going to do is, the talk really combines two parts. The first, and it represents the combination of two lines of research. The first part is how spoken language structures space. And a number of people, including myself, have worked for several dozen years trying to work out how language structures space. And we're now at a position, with all this research under our belts, to give what might be the fundamental structuring system that language uses for representing spatial scenes. So that's what I'm going to primarily present, the system that spoken language uses for representing space. And in doing so, I'm going to concentrate on what I introduced in the first talk, closed class forms, because as I was arguing the first time, there's a division of labor between open class forms and closed class forms. Open class forms are devoted to representing conceptual content, and closed class forms are devoted to representing conceptual structure. So, since we're interested in how language structures space, I'm going to limit myself to just what closed class forms represent about space. And then the second part of the talk is to look at sign language. In particular, I'll look at American Sign Language. I'm a novice in this, I'm no expert, but I've worked with enough individuals and that I think what I say is and it's been, what I'm going to say has been more or less approved by real experts, including deaf signers. So it's probably fairly reliable. And just a little background to sign language research. There was a time, maybe 30, 40 years ago, at least in the States, I don't know about the rest of the world, when sign language was totally dismissed. It was not considered a real language. It was just considered a bunch of random gestures. And then progressively, more and more research showed that sign language was an amazingly subtle, flexible, delicate system for representing thought, and it was a real language. But in the early days of research on sign language, it was probably felt to be politically necessary to still prove that sign language was a real language, and it seemed like the way to do it then was to show that it had the same properties that were then being ascribed to spoken language. So, which was in those days Chomskyan linguistics. So, a lot of sign language research tried to show how much sign language was just like spoken language, followed all the same rules, fit into the standard universal grammar model of spoken language, and in fact, therefore, was governed by what was then proposed by Fodor and also by Chomsky as a module, the language module, which is like a distinct brain organ dedicated to language. So, politically, to prove that sign language was a real language, the researchers, I think, felt obliged to show how closely sign language followed this Chomskyan Fodorian kind of module. However, in the intervening time, and meanwhile, sign language has has gained enough of a status in intellectual and academic communities and in the public in general as a real language. So it's not necessary to bend over backwards to prove its status as a language anymore. And in fact, now it's politically feasible to notice that there are in fact actual differences between spoken language and sign language. There are a number of differences. And in particular, I'm going to dedicate this talk. This talk is all about what those differences are. It's how sign language and spoken language structure space differently. And therefore, what it winds up as is as a challenge to the Fodor module of a single language module. And it's going to end up proposing that instead of a single language module, which handles both spoken language and sign language, that I would propose a much smaller core language system, which is neurally in the brain, which is responsible for what is common to both spoken language and sign language. And then that this core model, in turn, interacts with other outlying systems, brain systems, cognitive systems, for the full realization of one or the other of the two language modalities. So, in particular, this core system interacts with, most closely with visual perception, the visual perception system, cognitive system, together to give you sign language, and it interacts with another system, which I haven't named, but is tentative, to give you spoken language. But I'll propose what I think this other system is like. Okay, so that's sort of the background. So let's then start with the first part, which is seeing how the spoken language organizes its structured space, how it organizes its spatial delineations. And the first thing to look at is just what kinds of closed class forms are the target of the investigation. So that's the first part. And basically there'll be a whole range of closed class forms that represent things like paths and sites and so forth. And they will include closed class forms that are in construction with a nominal, such as English prepositions like on or above, or prepositional complexes like in front of. It'll include suffixes like the Finnish illative suffix, which means what? Into, I guess. It'll include complexes like the Japanese concept. It'll include these sort of spatial nouns that, for example, Japanese has, and actually Chinese has, as far as I understand it, to some extent. Things like ue, meaning top surface. So that to say on the table in Japanese, you would say at the top surface of the table. So these would all be kind of closed class forms that associate with the nominal to represent space. So that'll be part of the target. There will also be closed class forms that are in association with a verb. So English has, some might call them satellites, verb satellites. They include things like forth, they went forth, they ran apart, he ran back. They're not prepositions, they are in association with verbs, and they also represent space. They'll also include things like home, which in English means at home, like he's home now. They'll include deictics like this and that. They'll include indefinites like wherever and wherever and whatever they've got there. They'll include deictics I did like this and that, and also forms like that indicate degree of distance, like way or right. Like you say, it's way up there, it's right up there. So all of these will be closed class forms that represent spatial properties in spoken language, and so those will be the main target of this investigation. So, and I'll skip the next two kinds of things. So, here's the, let me give sort of like a summary of the findings. And the findings come in 3 sections. The first section is, it pertains to the fundamental components or elements that constitute the spatial system. It looks like, the way to get at them is you have to look at closed class spatial schemas across languages and start analyzing them. And they analyze down to what looks like a roughly closed set, an inventory of fundamental elements that are used time and again, that combined in certain patterns to form the full-blown schemas, spatial schemas that are represented by closed class forms. So we're trying to analyze down to what are these fundamental particles. And so it looks like there's an approximately closed inventory of fundamental spatial elements. And furthermore, that these fundamental spatial elements group together into some lesser number of categories. So these would be also part of the inventory, some roughly closed set, however large, of categories that these more fundamental particles, fundamental spatial elements fit into. And the third aspect of this is that, therefore, each category will have some relatively small fixed number of fundamental particles that belong to it and nothing else. So just those and none others will be the concepts that can ever be used to fit into a whole spatial schema. Okay, the second thing is then at the level of the whole spatial schema, the finding is that these fundamental components combine together into larger, more elaborate schemas. And so that's the full schematic form, and these are the schemas that are represented by particular closed class forms, full-blown schemas. And any given language, any single language, has some relatively closed number of such schemas that it can represent, because it has some relatively closed number of spatial closed class forms that will represent such spatial schemas. There will be, because of polysemy, there will be more schemas will be represented than there are actual closed class forms. But in any case, the number will be relatively smallish and finite. And the way you can look at these schemas is that for any given language, they represent a kind of prepackaged complex of the fundamental particles, the fundamental components, in a particular arrangement. So each language makes available to the speakers a relatively closed, relatively set of prepackaged assemblies of schemas built up out of these fundamental particles. The third part of the way the spoken language is, I should immediately point out that almost none of this is the way sign language is going to do it. Everything that I'm now saying is going to hold for spoken language. Almost none of it will hold for sign language. So we're already dealing at a level so fundamental that you're going to wind up seeing two language systems which differ at this fundamental level. Okay, so the third thing is that there are spoken language, then, as part of the spoken language spatial system. It has processes and properties that pertain to the full schemas. These are processes that generalize them or that permit them to plastically extend in certain ways, and also it permits them to become deformed in certain ways. And my guess is that the reason you need this third system, this third subsystem within the spatial system, is because since any given language has a roughly closed set of possible schema patterns to represent spatial situations, it needs to do something to be able to represent the infinitude of possible spatial arrangements. And so what it does is it has this third subsystem for extension and deformation that then lets the closed set of prepackaged schemas be able to apply to a much larger set of actual spatial schemas. Okay, well that's the sort of the overview of what the language system is going to look like, and now I'm going to elaborate it. So first, let me describe the methodology I'll use in finding the fundamental components that belong to the inventory. The method is you have to start with some actual closed class form. And the one I'll start with is the English preposition across in its locative usage, as in the board laid across the road. So I'm going to start drawing diagrams here. So like here's a road, and here's a board, and here's the board laying across the road. So the methodology is going to be to across itself as a word constitutes a whole complex combination of these fundamental particles. So how are we going to discover the pattern of particles? The method is to systematically alter one factor at a time within this situation and see if the word across still applies to it. And if it does, fine. If it doesn't, we know that that change we just made, that element we just changed, is criterial to the composition that across represents. So for example, and we're going to now go through a set of these elements. So the first thing we need to know is that there's two parts to this. There's the board, which is what I call the figure, and there's the road, which I call the ground. So we've got the figure and the ground. So this much I ask you to grant me, that this particular spatial closed class form across requires a figure and the ground. It's a relationship between the figure and the ground. And furthermore, the ground has to be a ribidal. It has to be some kind of plane which is narrower than it's wide, something like that. I can demonstrate that elsewhere. But now let me go through some additional parts that have to be true for you to be able to use across. Well, first of all, the figure, the board, has to be linear in character. If it were planar in character, like a plane, you would no longer be able to use across. If this is the road, and this is some wall siding, you would now say the wall siding lay over the road. You wouldn't say lay across the road, typically. So we now know that one component that across requires is that the figure must be linear. And we can start adding these up. Here's the across word. We're going to have, number one will be figure is linear. And we're going to add them up. And if it's planar, then we're all of a sudden in an adjacent word, the word over. Okay? So that's how we're going to do it. So the next thing is the across schema. What if we move the board? Right now, the board, the linear board, is perpendicular to the main axis of the road. The figure's length is perpendicular to the main axis of the ground. What if we make it parallel? It's like this. We can no longer say that the board is across the road. Now we would have to say the board is along the road. So you can add here, I'm not sure where I am, but 2 is perpendicular, and if it's not perpendicular, then you're already in the realm of along, another outline. So now we've got 2 elements, components, in the across schema, namely, or we've got more. It has to be a figure in the ground. The ground has to be like a strip. The figure has to be linear. The figure has to be perpendicular. Okay. There's more. The figure, in addition, has to be parallel. The plane of the figure has to be parallel, or the line of the figure has to be parallel to the plane of the road. Because if it's like this, if it's not, then you would have to say the board is sticking out of the road. You could no longer say the board lay across the road, or is across the road. So that's another feature. Yet another one is the plane, the line of the linear figure has to be adjacent to the plane of the ground. Because if it's not adjacent, if it's like this, you can no longer say the board is across the road. You have to say the board is suspended or is over the road, is above the road. So now I've got above instead of across. Or if it's in there, you just have to say the board is in the road, not across the road. So that's another feature that's necessary. Yet another one is that the length of the figure has to be at least equal to the width of the ground. So here's the road, here's the board. Its length is at least equal to the width of the ground. What if it's not? What if it's smaller? Well, here's a baguette, a French loaf of bread. You can no longer say, everything else about this baguette is the same as before. It's perpendicular, it's adjacent to the road, it's everything else I've had about the board still holds for it, but we still can't say that it's across the road. We now have to say simply the baguette lay on the road. So we can't, we've lost across again. We're still not done. Here's a road, and I could put a board like this. Well, this fits everything that I've listed so far, all the components I needed for a cross, for the board. It's perpendicular, it's parallel, it's adjacent, and so forth and so on, except you can no longer say it's a cross. The best you can say is one end of the board lay over the edge of the road. That's the best you can do. With that one, you certainly can't say a cross. And we're still not done. Over here. Another requirement for a cross is that the figure has to be horizontal. Whereas the ground, the road, is typically horizontal, but it can be vertical. So let's say this is now a wall, and we've got a spear hanging on the wall. Well, we can now say that the spear is hanging across the wall. That's fine. But this, you cannot say across. Now you have to say the spear hung up and down on the wall, or something like that. But you can't say across. So a final component of the across schema is that the figure has to be horizontal. Okay, so this is the methodology, and by this method alone, we already know that we've already isolated some components that from the total schema, so that the across word represents a total schema, spatial schema complex. We've already been able to isolate certain components within that schema which are necessarily on this proposed universal inventory, this universally available inventory. They're necessarily on it. After all, we found some language with some closed class form representing some whole spatial schema which has it. So therefore it's on the inventory, the available inventory. And we've already therefore learned that on this inventory will be such primitive components, spatial components, as a point, a line, a plane. We've needed those just to describe the cross. Figure and ground are part of it. Perpendicularity is part of it. Horizontality. Well, I forgot to mention that the horizontality actually means to be parallel to one of the Earth-based planes. The Earth itself defines a grid, a vertical grid and a horizontal plane. So for something to be horizontal means to be parallel with that horizontal plane. So horizontality, parallel, perpendicular, adjacency, these are all fundamental components that are going to be in the spatial inventory. Also boundedness, so a point bounding a line bounding a plane, and so forth. These are just from this one spatial schema. We were already starting to fill in the inventory. Okay, well, this methodology requires that you consider possible elements that are not going to show up on the inventory. So one element to consider is, let's say, here's the board. Well, the board happens to be planar itself. So maybe, and the board was aligned like this across the road. So maybe we should test out, maybe you need a concept of a planar figure, planarity, and a particular coplanarity, that the plane of the board is coplanar with the plane of the ground, the road. Is that a necessary component? Well, the answer is no, not for the word across. The word across doesn't care. You could have the board lying this way. You could say the board stood across the road on an edge, or lay flat across the road. Either one. The word across is unperturbed. It still stays there, so it doesn't care. So maybe coplanarity should not be on the inventory. But wait, first you look around for other closed class schemas and see if it ever gets used, and sure enough, it does. In another English schema, the one for over, one of the meanings of over, as in the tapestry hung over the wall. Well, here's a tapestry, here's a wall, tapestry hung over the wall. It has to be coplanar. You would not, if this is a string of beads, you wouldn't say the string of beads hung over the wall. You'd say it hung against the wall. So you need a plane here to say that the tapestry hung over the wall. Well, that's coplanarity. So sure enough, we just look a little further outside the word across, and now we do find coplanarity. And so therefore that also has to be one of the fundamental elements that's on the inventory. Well, let's go further. Let's test further. What about the category of the property of flexibility and or rigidity, and the category that it would belong to, degree of rigidity? Well, you can test it out with a cross, and you could try using a flexible cable. If a flexible cable lay that way, would you say the cross? The answer is yes. You'd say the cable lay across the road. So the word across doesn't care if the figure is a flexible thing or a rigid thing, like a board. It doesn't care. And then you go look around for some other words, and you might have a hard time ever finding any spatial schema that cares about the state of rigidity of any of its objects. If that's true, if that holds out, then that concept, degree of rigidity, would not show up on the inventory. It just wouldn't be one of the fundamental spatial elements. So that's the methodology. For ascertaining what the fundamental elements on the inventory are going to be. And you have to look around all the world's languages. I mean, you can't do everything, but you certainly have to do a lot of spot checking to see what other distinctions other languages are making than just English. And which is something I've done, by the way. So there's a number of distinctions that English certainly doesn't make that other languages do, and they're on the inventory that I'm trying to build up. So, okay, another guiding principle in building up this inventory and determining what's on it is to never specific than you need to. You always go down just to the level of granularity that's required that the spatial forms themselves are requiring. So for example, let's take, there's another category, one of the fundamental categories on the inventory is separation of orientation or something like that. Anyway, it's a category about relative orientation. And it would have at least two member fundamental components within this category: parallel and perpendicular. So we have parallel and perpendicular. In addition, there seems to be some indication that some languages require a third distinction besides parallel and perpendicular, namely oblique. So, for example, in my English, I'm not sure all speakers agree with this, but in any case, in my English, these words make a distinction. If you say what is it? Auxiliary pipe? No, what is it? What's my? Well, let's say a secondary pipe branches out from the main sewer line. So here's the main sewer line, and here's a secondary pipe branches out. If you say out, it's perpendicular, so that's fine. If you say a secondary pipe branches off from the main sewer line, to me that's oblique. So, and also I found some in Athaewi, the American Indian language that I worked on, also seems to make that distinction. In one of its cause prefixes, if a linear object is oblique, like poling a canoe, like that, it uses one prefix, but if you push down or perpendicularly or poke, it uses a different one. So it also seems to require this distinction between perpendicular and oblique. Okay, fine. So we've got probably three distinctions within this category of relative orientation. But no more. You don't need anything finer than those three. Now, this is into other cognitive systems. We've got a lot of other cognitive systems, for example, vision and motor control, and you can easily see further distinctions of angle, and you can certainly feel them, but it seems like nothing finer than that ever makes its way into the linguistic system for representing spatial structure. I failed to make this point well enough in the first talk yesterday. Let me draw this point out again. I was showing that the word across is magnitude neutral. So you can say the ant crawled across my palm and the bus drove across the country. So the word across abstracts away from magnitude. But other cognitive systems don't. We have plenty of cognitive systems that are able to discern the difference between these two magnitudes. We have cognitive systems that can tell the difference between being able to see something within a single scope of attention versus the bus trip across the country. You can't possibly do that. Or to cognize it within a single span of attention. You can do that with an ant crossing the palm. You couldn't do it with the bus crossing the country. Uniformity of seeing. It's uniform with the ant and the palm. It keeps changing with the bus in the country. We've got cognitive systems that can distinguish all of these phenomena, but none of that makes it into the cognitive system that is dedicated to closed class forms in language. Instead, all that makes it into those forms is the abstracted, idealized delineations of its schemas, which is what it cares about. The across schema, like this line here, and an arrow, that's all it cares about. Everything else is abstracted away. Well, the same is true here. In this case, it's the degree of fineness, the degree of granularity is highly limited for spatial distinctions. As far as it goes into this structuring system that language uses for space. Okay, so now, with this as the methodology, we can now start laying out, well, what are some of these categories and the members that are in them? All right, let's start that. And I'll spend some time now doing that. So there's you can divide this inventory into three types of categories. One type of category pertains to partitioning the whole of some spatial scene into major parts. Another are those categories that pertain to the spatial properties of just one single element, one of those parts. And a third class within this is those categories that relate one part to another part, relationship between two parts. So let's start with the first one. The first one is how the whole scene is partitioned into principal parts. And there seems to be exactly three member notions to this category: figure, ground, and what I call secondary reference object. Those three and nothing else. So we've seen already, you don't need a fourth element or anything. So we've already seen figure and ground, so now let me organize, let me illustrate the secondary reference object. And there's two types. One is encompassive, so let me show that. And this distinction, okay, thanks. This distinction, it can show up in different prepositions in English. They'll differ as to what they require in the way of a secondary reference object. If they require just figure and ground, or if they require three scene components. So the word near just requires two. If you say the lamp is near the TV, okay, well here's the TV, here's the lamp. The TV is the ground, the lamp is the figure, the lamp is near the TV. The word near doesn't care about anything else. It's just those two things. And the lamp could be anywhere within a certain perimeter. But if you now say the lamp is above the TV, or over the TV, then it not only has to be near it, because over requires proximity, but it also has to be vertically aligned with the TV. Well, what is this vertical alignment? It's part of the Earth-based grid. Here's the Earth-based grid, here's the horizontal plane, here's its vertical axis. So it has to be aligned with it in terms of the Earth-based vertical axis. Okay, well that's the third thing. So the word above requires not only two things, the figure and the ground, same figure and ground, but also a third thing, a secondary reference object. In this case, it's what I call a encompassive third thing. It's the Earth-based grid encompasses everything. In addition, there is an external, you can have an external type of secondary reference object. And that is, okay, take the word past. So here's a border, here's a car, which has been here and it's driven, and now it's over here. So I can take my binoculars, and I can look at it from this side of the border, and I can say, the car is past the border. And I can look at it, I can step over here and do the same thing and say, the car is past the border. Fine. So all that past everyone cares about is two objects, the figure, the car, and the ground, the border. Just cares about those two objects. But if I now say the car is beyond the border, it takes a third thing, namely, it demands that your viewpoint be on this side, the opposite side of the border from the car. I can only say, the car is beyond the border when I'm here. I cannot be over here and say, the car is beyond the border. So it means that beyond, in addition, requires this third thing. It's an external secondary reference object, namely viewpoint location at a particular place. Okay, so that's the only example. That's filling out this first class of distinctions. It's the division of the whole scene into major scene components. Now, let's look at the next class, which is the properties of individual scene components. Well, I'll go through 5 of them. The first one is just the dimension, and to be sure, there are 4 of them. And it turns out that English has prepositions which are specific as to the number of the dimension for its ground object, for the ground object. So, for example, near just requires a point ground object. So you can say near the dot. Here's a dot, so it's near the dot. But along demands that the ground is one-dimensional, a one-dimensional line. So like I walked along the path. Over, as we just saw with the tapestry over the wall, flat against the wall, requires two dimensions, a two-dimensional plane. It demands that the plane, that the ground, the wall, be a plane. It also demands that the figure be a plane, but we're just talking about the ground right now. And finally, the word throughout demands that the ground be three-dimensional, a three-dimensional volume. So if you have, here's a bunch of jelly, and here are strawberries, and you can say there are strawberries throughout the jelly. That means they are dispersed over a three-dimensional volume. So throughout demands a three-dimensional volume. So now it may not be fair to, in this case there's no real restriction, because after all there are only four dimensions, the 0 through 3. So it's, and in fact the system has all four of them. But at least we know that all four are in use by actual spatial schemas in language. The next one is more restricted, and I call the next category dimension. Number. And there's, it looks like there's only four member notions within this category. One, two, several, and many. Nothing else. So, for example, if you have, you can say the bike is, the word near, again, only requires one. So the bike is near the boulder. Between requires two. The bike is between the boulders, means two. Among requires a few, several. So this is the bike is among the boulders. And amidst requires numerous things, like the bike is amidst the wheat stalks. So there's that. So there's one, two, several, and many. But it looks like no spatial schema in any language ever requires any other number than those four. There's nothing that requires three. There's nothing that requires, that has a notion of too many. There's nothing that has a notion of a dozen, and so forth. It's all absent. And furthermore, on the first talk yesterday, I described how there is this constraint in general on closed class forms as to number. Well, what kind of number can be ever represented by a closed class form? Well, it's even more restricted when it's a spatial schema. It's just those four. There's more than those four if it's if you're talking about closed class forms in general, but just these four if it's spatial. Okay, the next category is mode of state. Is that right? Mode of state? Okay. And there's two members in this category, stationary and moving. There's two member notions, two member elements. And in fact, once again, English has prepositions which are sensitive to whether the figure is moving or located, or whether the ground is moving or located. So let's take a stationary ground and a moving figure. So the word at requires that the figure is stationary. So for example, you can say, I stayed at the library, but you cannot say, I went at the library. That's out. It has to be stationary. The figure has to be stationary if you're using at. On the contrary, into, as a preposition, requires that the figure move. So you can say, I went into the library, but not, I stayed into the library. Okay, so built into these prepositions is, in this case, one of the state of motion components, stationariness, and this requires motion. In addition, there are closed class forms in English, prepositions that are sensitive to whether or not the ground is moving. So, for example, let's say you've got a moving figure, like a lion running along, a lion. And here's a deer, here's a lion, here's a deer. If the deer is also moving, you say the lion ran after the deer. But if the deer is stationary, we say the lion ran up to the deer. So these, again, distinguish whether the motive state of the ground in this case. So stated bounded, oh, I should add that there are, you might have thought that there could be other motive states. There could be moving slowly, or speeding up, or there could be, in fact, sign language represents three motive states, it seems, moving, stationary, and fixity, something fixed in place. But it's just two in spoken language. So, okay, so next is stated boundedness, and again, they're just two members, bounded and unbounded. And there are, again, some prepositions in English distinguish whether the ground is bounded or not. So proceed. So for example, if you've got, here's a pier out into the water. Here's the water, here's the pier. And if you use the word along demands that it be unbounded. So dot, 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 dot. I walked along the pier, dot, 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 for 10 minutes. You can say for 10 minutes. You cannot say, I walked along the pier in 10 minutes to mean from beginning to end. It is not possible. On the other hand, there is another prepositional complex, the length of, which has the opposite properties. The length of, I walked the length of the pier in 20 minutes, that's fine. But you cannot say, I walked the length of the pier for 20 minutes. Some kind of unbounded. So this one requires boundedness, this requires unboundedness. As it happens, most prepositions in English are polysemous for both bounded and unbounded interpretations. So for example, if this is a tunnel, then you can say I walked through the tunnel with the word through for 10 minutes, that's fine. And I walked through the tunnel in 10 minutes, that's also fine, but now means from this end all the way to the other end. So through permits, is polysemous, it has both an unbounded sense and a bounded sense. State of consolidation with two members, one is, if you say, so let's contrast to for. If you say she'll be waiting there is kind of neutral, could be, but if you say she'll be waiting thereabouts, thereabouts is one of these spatial schemes, which means approximately in some general larger area, whereas there is kind of neutral to whether it's confined or extended. Similarly, at and around. So she'll be waiting at the landmark. Let's say here's the landmark. She'll be waiting at the landmark is pretty close. She'll be waiting around the landmark means in some approximate location of some general area. And some of this is built in systematically to some languages, like in Malagasy. Apparently there's a systematic set of diptychs that are used for, and they're typically accompanied by different gestures. So the compact one would be like it's there. The diffuse one would be it's there with a sort of a spread of the hand, sweep of the hand gesture. So okay, so those are those five. And so those are all illustrate distinctions, categories within the class of looking at the spatial properties of just a single scene component. Now let me go to the third class, where there are things that show the relationship between one scene component and another one. We've already seen one, it was relative orientation. In addition, there is a degree of remove. So let's look at that. So there's 4 or 5 basic members to that and no others. There's 4 with context, so there's coincidence and adjacency, and then 4 without, 2 without contact, proximal, distal, and maybe you need a medial for some languages. So, and in English, English, again, you can see all four at work in different ones of its prepositions. In this case, you have to sort of tease out the distinctions. So let's start with, there's this prepositional complex, which is in the front of. I'll take it with the word the. In this case, you have to have the word the in there. In the front of. So this is a fairground, and here's a carousel, a merry-go-round. You can say the carousel is in the front of the fairground. That means it's in the front portion of it. So this is an example of coincidence. In the front of gives you an example of coincidence. The figure is coincident with the ground. They co-occupy the same point. If you say in front of without the, it automatically means that it's proximal. It's not in contact with proximal. Here's the carousel. Here's the, let me redraw. Here's the fairground. Here's the carousel. Now you've said the carousel is in front of the fairground. It means it's proximal. It can't be touching it. You wouldn't say it that way if it were. It can't be distal, because you cannot say the carousel is 50 miles in front of the fairground. So we know that it's proximal. Okay. There are also cases that distinguish, there's other prepositions, like, let's say here's a table. Here you can say the fly is on the table versus the fly is over the table. On requires adjacency. So it's the second one of the contact possibilities is a degree of remove between figure and ground. Whereas over has to be proximal. It can't be contact. It has to be no contact and close. Because again, you can't say the fly is 50 feet over the table. But just in order to now distinguish, to tease out the distinction between proximal and distal, you can. Over cannot say it's 50 feet over the table. You could say it with above. The fly is 1 foot above the table. The fly is 50 feet above the table. So in this way, you can sort of tease out these distinctions, just still, again, using English prepositions. So this is now an example of this third class of categories, namely relating one of the basic scene components to another. And there's many more. So how many categories are there all told? I don't know. I haven't worked it out, but I imagine it's on the order of 50 or so. These are just a sampling. And then the point is that within each category, there's a constrained number of member elements that are possible within them. No more. Those and no others ever seem to show up in languages. So it's an extremely constrained system. Okay, to fill out the way the system works further, it turns out that a lot of spatial schemas are, curiously, often accompanied by concepts that are not geometrically spatial. And it happens so often that a number of them, some of them occur so frequently together that they have to be mentioned here. And one of them is force dynamics, which I described yesterday. So in particular, for example, the word on in English, it has a spatial geometric component. It requires that the figure be in contact with the ground. So you can say, for example, there's a poster on the wall. So it has to be adjacent, but not just adjacent. It also has to be supported in that location against the pull of gravity. So that's the force dynamic part. Gravity might be pulling it down, but some kind of process, perhaps glue, is acting so that it force dynamically acts against the pull of gravity. How do I know this? How can you tease that fact out? Well, let's say here's the wall, and here is a balloon filled with helium, and it is now not glued on. You would now not say that the balloon is on the wall. You don't say the balloon is on the wall. You now say the balloon is against the wall. So now it turns out that against is the preposition in English you use for geometric adjacency, but without force dynamic support. Okay, so that distinction shows up there. So that's force dynamics. In addition, just to do one more of these non-geometric ones, let's take this kind of like a combination of a notion of accessibility or inaccessibility, which is perhaps geometric, together with a kind of like an affective attitude, which is something like mysterious, risky, strange, and so forth. So, and that is rather frequent. I'm surprised how frequent it shows up in spatial preposition-like things around the world. But anyway, English has it in the word beyond. So if you say, here's the same car, and I say he's beyond the border, I'm not only saying all this, that the car is the figure, this is the ground, and my viewpoint is on this side. I'm also saying, with the use of that word, that there's something risky, mysterious, impenetrable about that location. As opposed to, if I said, there's another locution I can use in English, the car is on the other side of the border, which also requires, everything else is the same, it requires viewpoint over here, but now all the mystery is dropped. No more strangeness. So, for some reason, mystery seems to want to accompany words like beyond. Okay, so now I'm going to switch to section 5. Now, let's switch to the second aspect of this whole spatial system in spoken language, which is putting those things together again into schemas. And this, it turns out, is the part of the whole enterprise, which is the least, which I understand the least. You'd think that there would be principles of well-formedness that govern how the primitive components can be combined together, arranged into particular patterns. But I don't know what they are. I haven't found them. And some especially elaborate Byzantine combinations, like showing with the word across or past, recur in languages around the world. While others that you might think of seem never to occur. So let's in fact go through the word past and show you how it's assembled. I'm not going to go through everything, but let's say there's a sample sentence, the ball sailed past my head at exactly 3 o'clock. So that would be something like, here's a ball, goes like this. Okay, so it turns out that with all the categories and primitive components that I've found placed on this inventory already, just using those, this complex schema can now be completely or seemingly exhaustively characterized. And the list shows you everything. I mean, among other things, the ball is the figure is idealizable as a point, so is the ground as a point. The motor state of the ball is moving, not stationary, and so forth. It describes a line, which is one-dimensional linear path. But to show some of the particulars that are special so among other things, the ball has to go this way, to one side. If the ball went this way, you wouldn't say the ball sailed past my head, you'd say the ball sailed into my head. And if the ball were over there, you wouldn't mention my head at all. Just say the ball sailed along over there. Then the ball has to be to one side of my head. If it were in front, you wouldn't say past, you'd say the ball sailed in front of my head. If it were over, you'd say the ball sailed over my head. And it has to be horizontal because if the ball sailed this way, you'd say the ball sailed down alongside me or the ball sailed down in front of me. These are all the ways that you know that using the same methodology that I used for a cross, this is how past is built up. But then I thought I'd try to invent a preposition to see if it could ever occur, just using the same components that I had. So I invented a preposition, which I call a pit. It's my new preposition. And I say it should mean down into a surround, which is radially proximal to a center point. So for example, let's say here's a house, and here I dug a pit, and I poured water down into it. So that's the schematic configuration. It's built up out of all the pieces that I've already discovered. So I made a preposition up, which therefore I should be able to say I poured water, a pit, the house. But it doesn't exist, and no language has it. I'm disappointed. But for some, so what it is about past and across that permits such elaborate combinations and doesn't permit something like a pit, I don't know. Okay, so that's the second aspect to this. Now let's go to the third aspect to the spoken language spatial system, and that is each language, therefore, has some relatively closed set of these schemas, each represented by some closed class form. And the thing is, how does spoken language then make that do for all the thousands of spatial situations that arise? Well, it uses these processes of plasticity. The same schema can be extended and distorted and so forth. So we already saw some examples of extension and generalization. The first lecture, which are repeated here, for example, there's the topological character. The same preposition, like the cross, can be used regardless of how big the path is. So it's magnitude neutral. And the word through can be used regardless of the shape of the path. So I zigzag through the woods, I circle through the woods, and so forth. So those we already discussed. So those are examples of plasticity that, or generality, that allow a single preposition to cover quite a wide range of, where sign language would never represent these two different throughs the same way. It would represent them much more like I'm showing you. They wouldn't be grouped together into a single word through. Similarly, so let me skip to a new example of extension, and that is the one which I'm calling extendability in ungoverned dimensions. So let's take the word out in English. It has the word out has a radial sense. So you can say here's an island. You could say the boat slowly drifted out from the island. That suggests a set of concentric circles and moving along a radius through that kind of imposed radial geometry. That's what out means in English. If you didn't want that, you'd say away. The boat slowly drifted away. That would give you kind of like a rectilinear sense. If you want the radial sense, you use out. Okay, well, now you can extend all this. You can, here's the island. You could say a caravan of boats slowly drifted out from the island. So that's, instead of the one boat, we can fill in this radius. Or instead, here's the one boat, you can fill in the circumference. You can say something like a ripple spread out from where I threw the pebble in. Again, it's out. The word out stays the same. It's out, out, out. Or you can say, you can fill this in. The disk would say the oil spread out from where it spilled. Or you can take this circle and close it over into a sphere and say as I blew out of the balloon slowly puffed out. Or you can fill in the interior and you could say the dough puffed out. So the word out keeps getting used for all the additional dimensions that that are not built into its original definition. So that's another form of extendability. So in addition to extendability, there is deformation. So for example, you can do some degree of stretching. So let's say this is a perfect across. If it's square, you're fine. That's across the swimming pool, a square swimming pool. If this is a swimming pool like that shape, you could never say I swam across the pool. It's too long. You'd have to say I swam along the pool. But what if it's sort of square, but just a little bit longer, so it's rectangular? Could you say I swam across the pool? Sure. So if you stretch it a little bit beyond what its ideal schema is, then you're still fine in English. So that's stretching. In addition, you can deform. You can cancel certain features. So you can cancel one element of the across schema. For example, here's a boulevard. Here's a shopping cart. You can say the shopping cart rolled across the boulevard, but was hit by an oncoming vehicle. Was hit by an oncoming car. Well, that means it can go all the way across. So we don't have a full across schema, but it doesn't matter. You can still say across. You can cancel the feature of the across schema, which terminates on the further boundary. In fact, you can cancel both parts. Here's a desert, or let's say here's a sand-level playground. You can say the tumbleweed, it's a kind of weed that rolls along the ground. Tumbleweed rolled across the playground in 5 minutes. But here's a desert. Here's a tumbleweed. You can say the tumbleweed rolled across the desert for an hour. No bounds, no boundaries on either side. So again, we've now used across, the same word across, by canceling both of its, two of its components. So this seems to be the way that spoken language adapts. It sets up a sort of closed system of prepackaged schemas, and then it distorts them in order to get you the rest of the thing. Okay, now I have to switch to sign language. So we've just gone through the whole, the main features of how the spoken language system works. So in sign language, the first issue is, well, what to compare with what? They're not fully comparable systems. Spoken language has certain subsystems. It has the open class subsystem, the closed class subsystem, and what I call vocal dynamics, and you want to include gesture and body language. So fine, let's say those are the major subsystems. Sign language has a different set. It has something comparable to the open class ones. It has what could be called lexical signs. It has a subsystem of modulating those lexical signs. And it has two systems which are missing in spoken language. It has what are called size and shape specifiers, gestures like this that show like this is a certain kind of bucket, or you're indicating, indicating a long, thin rod. And then there are the classifier system, which is what I'm going to concentrate on. I'll illustrate it in a second. And then there are a number of different categories, subsystems. Facial expressions are elaborately systematized. Gesture as a subsystem that moves in and out, and so forth. So it looks like the best thing to compare would be the spatial part of closed class forms in spoken language and the classifier system in sign language. So what is the classifier system? Every sign language, there are many of them around the world. I know there's a Mandarin one. They're not related to the spoken language. Typically, they're not related to the spoken language at all. And they have more commonalities among them than they do the spoken language. And the classifier system is dedicated to representing one object moving with respect to another object in space. That's what it's dedicated to. So to illustrate it, this could be represent a ground vehicle. Could represent a tree. This is the car drove past the tree. This is the car drove past the tree up a hill. This is the car drove past the tree up a curved hill. This is the car drove past the tree up a bumpy curved hill. This is the car did it fast. And this is the car started close to the tree and went further away from it. So the way that this is solely within the classifier subsystem. It's a specialized system. It's not the system of signs, of normal signs. Like this is the sign of the book, this is the sign of give, and so forth. It's not those signs. It's a specialized subsystem of its own. And it has its own set of shapes of hand representing kinds of things. Those are called classifiers. So this is a ground vehicle, this is an air vehicle, this is an animal, and so forth. And you can pile up lots of concurrent aspects of space all at once, just as I just showed. And there's reasons to want to associate the classifier subsystem of sign language with this closed class spatial system of spoken language, and they have a number of properties in common. First, in terms of the first talk, I made a distinction between the content versus structure of concepts. Both of these subsystems are on the structure side of this division. So, well, yeah. And so, for example, spoken language, or let's say English, has open class forms like enter, but it has a closed class form into. Well, the same kind of distinction shows up in ASL, American Sign Language. This is the sign for enter as a real lexical verb sign. But it's not used at all in the classifier system. Instead, you have a number of more structural kinds of indications, like this would be one kind of enter, this would be another kind of enter, I mean into. It subdivides into a number of different subdivisions, but none of them look like the enter verb. Second thing is that both subsystems are used to represent spatial situations structurally. And the third is they can add what are essentially open class forms or lexical forms, if needed, to amplify the structural things. So in English, you could say, I drove in, rode in. Or you could say, I rode the motorcycle into the cave. So you can add parts like motorcycle and cave. You can do the same in the sign language thing. So you can either go like this, or you can give a sign for motorcycle. This is the lexical sign for motorcycle, and then go like that. So or in fact, you can spell out the word for cave, which I'm not good at, but it's something like this, and then go that, and then go this. So you can do the whole exact parallelism of expansion into lexical signs, just like spoken language. So first of all, the sign language system in general differs from the spoken language system in a number of ways. It's almost always in the direction of being closer to visual parsing, visual scene structure. It's in almost all sorts of ways, in that it has more. And it does so in two venues. In the first venue, it's in the inventory of available elements. So one is, let's look at the inventory. It typically has more, in its inventory, it has more distinctions, more categories, more distinctions per category than spoken language does. So first, there are some things which are in fact rather parallel. It has essentially the same number of distinctions for boundedness as spoken language. There's only bounded and unbounded. I mean, this is a bounded path, this is an unbounded path. This is a pizza hitting into the ceiling. You get the bounded part there. So it just has two categories. So that's pretty much the same as spoken language. There are some categories where it has just a little bit extra. I already indicated for the category of motive state, it has 3, it seems, at least by one analysis. Moving, stationary, fixed. There are other cases where it has, other categories where it has a small number of additional things. Let's see, a small number of things include, well, probably, yeah, degrees of, we should make sure that we're all in the same place. This is, do you all have the spot where it's located? Yeah, so degree of remove. In spoken language, I found 4, maybe 5 degrees of remove. Coincidence, adjacency, proximal, distal. My guess is that the non-contact ones are more finely divided. So if you drive past a tree, you could probably indicate more degrees of pastness than spoken language would. So it's a moderate degree more. Then there are cases where there's, the next one is where sign language inventory has an extensive degree more. So this would be the case for path contours. There's maybe only 4 path contours that are distinguished in spoken language. There's a circle like around the maypole. There's a curve like over a hill. There's a meander like walk around about the town. There's a straight one like walk across the plateau. That's about it. But there's an indefinite number of contours that show up for, that they can be represented iconically by the closed class, by these sign systems. Just show which way the car is moving. Furthermore, the sign system has categories which don't even exist in spoken language. For example, how close or far you are from a ground object when you start. So if you pass the car, if your car passes the tree starting far and ending soon, that's this. But passes it starting soon and ending far, that's that. That whole category of how close you are at the start or finish is absent from indication in any structural way by spoken systems. Okay, so now let's switch to the second venue, which is that the first thing is that within the expression, this is within the inventory. The inventory of sign language is much larger and finer granularity than spoken language in what I would say is something more resembling the visual scene parsing, what we do visually. The next is contrast in any single expression. Okay, well, an expression is okay. So the first thing is that it's iconic. It's more iconic. So it's iconic in a number of ways. So first of all, it's iconic in the way that it clusters components of the spatial scene. So if you actually look at a car bumping along past a tree, along the road past a tree, well, there is a kind of visual clustering. First of all, there's the kind of figure it is. It's a car. There is the manner in which it moves. You see it bumping. You can see that it is, in fact, in motion. You look at the car, you see that it's in motion, not stationary. You see the path that it's on. It's straight. Well, okay, well, that's good enough. Well, all of these, and what's different is, let's say, the tree, which is seen to be elsewhere. All of sign language clusters together all of these components just as it does in vision. It is faithful to vision. The same single hand clusters together the kind of figure it is, its state of motion moving, its manner bumping, its path straight, whatever it is. So all of this is clustered together. Every spoken language deviates from this fidelity in one way or another. So, for example, the closest English sentence that I might find would be the car bumped along past the tree. Well, in this, you've got the car, the figure, is indicated separately. It's not indicated together with, even syntactically, together with all the other elements of this one object. Bumped, that's its manner. and the fact of motion. The along shows its trajectory, its path, is unbounded linear. Past is the relation of this path to the ground, and then the ground object, which is separate. And one puzzling mystery for me is why spoken languages, in general, seem to represent the path that the figure executes in relation to the ground, next to the ground object. They don't indicate it next to the figure. So it's past the tree. They don't say the car passed or past car passing. But in sign language, it does. It shows the car, the same hand that indicates the car, and all the other factors also indicates the pastness, just as you would do visually. So it's really clustered together quite iconically. There are other aspects of iconicity that are maintained. For example, in all of all sign languages, it's the object that's moving is represented by the hand shape, whereas the way the object moves is represented by the way the hand moves. Now, I encourage looking at something from a Martian's perspective, and I thought of an alternative that could have happened, but never happens. And that is where it's the hand shape that will show you the path contour. So a straight set of fingers will show you a straight path. Curving the fingers will show you a rounded path, curved path, and zigzag fingers will show you a zigzag path. Okay, and then the way the hand moves will show you the shape of the figure. So this would be a round figure. This would be a straight figure. This would be a linear figure, and so forth. Well, therefore, for that system, this should mean a round figure moved along a zigzag path. But that doesn't exist. No sign language system ever does it. In fact, it's iconic. Again, every spoken language deviates from this iconicity in one way or another. So, for example, if you say, in English, the thing that's moving is typically represented by a subject noun. In Atsugewi, it's typically represented by the verb root. Similarly, the path in English type of language is represented typically by the satellite of preposition. But the path in Spanish is typically represented by the verb. So there's no iconicity. In fact, spoken languages differ from each other. Okay, and I'll skip the middle one, and the last iconicity is if you say, I think I'll skip all the rest of the iconicities. It's a matter of time. Okay, let's skip to number 10. Okay. Yeah. So it turns out that another seeming property of this classifier system is that it seems to represent only what you could see around a narrow scope of focus around the figure object. And I don't know if this is an example of visual fidelity or not, but it does seem to be characteristic. So you should expect to be able to express the kind of figure, its manner, any adjacent instrument next to the figure, and those should all be expressible, and they are. And in this respect, they parallel how English can express them. So for example, if you want to show the immediate instrument of it, like I plucked moss up off the boulder. Here's a boulder. Here's the lexical sign for boulder. Here's the classifier system symbol for it. And then you release one hand and you go like this to show plucking moss up off the boulder. So it's like this. Okay, fine. And you can say it in English in one clause. You can represent it in one clause, in one expression, in this classifier system. Similarly, you can express also an adjacent manipulator, like I pulled the jug along the counter. You simply go like that. You can say it in English. You can show it in a single classifier expression. Similarly, you should be able to express, within this narrow scope, an adjacent instrument. So for example, I scooped the jelly beans up into her bag, it would go like this. So here's the hand representing the adjacent instrument, the scoop. Scoop digging down, and you actually curl your fingers in, and then go like that. Okay, you were fine. You should be able to show adjacent manner, because manner, you can see the manner of the figure within a single scope of vision. So here's a cork on water. Here's a cork bobbing. Here's seaweed. Here's a cork bobbing past the seaweed. Fine, you can do it. You can show it within a single gesture. You can say it in English. Now, all of a sudden, though, as soon as you try to go outside that narrow scope, English keeps on going. Sign language stops. The classifier system stops. So, for example, in English, you could say, I kicked the ball over the goal post, something you can do with American football. Well, it's one clause in English. It's now impossible to do it in one classifier expression in ASL. You have to do it in two. Kick, here's the kick part, and here's the goalpost, and here's the ball going through it. You have to now do two separate gestures. This is apparent because they are temporally separated. The kicking of the ball and the ball's subsequent path are separate events. English is perfectly happy combining them to a single clause, even though they're temporally separated. But the classifier system won't let you. Similarly, if you try to look further away from this narrow focus, again, you can't do it. English is still fine. So you can say, I walked the memo to the home office. I ran the memo to the home office. I flew the memo to the home office. Sign language can't do that. The best you can do is you can indicate in two gestures. Grab the memo, or took the memo, and drop it, and then rushed. So, two separate gestures. You can't do anything like holding the memo, showing yourself running along. That's impossible. And in fact, if you do this in front of some signers, they laugh aloud. And okay, so that's another property of the way that the classifier system differs from, say, spoken language. Finally, another way is the sheer number of distinctions. This is 11. The sheer number of distinctions that are possible to be indicated simultaneously. They're enormous. At most, I have found 6 in the spoken language. English is pretty good. In English, you could say something like, the bat flew way on up into its niche in the ceiling. So here's a cavern that a bat flies, and the bat flew way on up into its niche. So you've got way, meaning a long distance, on means continuation of a path, up, vertical axis, positively. In indicates concavity. To indicates path instead of motion instead of locativeness. So what is that? 6, something like that. By my count, the classifier system can make as many as 30 categories of distinction, perhaps in principle, all of them simultaneously. I'm sure it never happens. There's got to be, there are co-occurrence restrictions. But you can get, in any case, many more than you could in spoken language. And many more combinations of things together than you would have thought possible in spoken language. So, for example, you can indicate just, and I list the 30 there. So under figure properties, there's 3 distinctions for the size of the figure. So this would be like a small circle thing, maybe a small pizza, medium pizza, large pizza. You get a three-way distinction. And you can also indicate depth concurrently, independently. Small, whatever, film case, larger film case, or bowl, small bowl, medium bowl, larger bowl. So you have 2 size things in 2 dimensions. Or here's another one that does size dimensions. So this is toilet paper coming off a roll. This is film coming off of a spool, reeling off of a spool. This is cable coming off of a spool. And this I sometimes think that is used like a diminutive. This could be like thread coming off a spool. So these are those distinctions. In addition, let's just to pick one, I distinguish three kinds of motion. I did this in spoken language before, and it turns out it's equal in sign language. So there's internal motion, which includes where anything changes its shape. So this could be a rolled up piece of paper that you let it go and unfolds and opens up and settles back down onto the table. Okay, that's indicating internal motion. Then, in addition, there's confined motion, which is just rotation. So the roll of paper could move this way, that way, or this way, that way, some kind of oscillation or rotation. In addition, there's translational motion, where it moves through space. Well, you can indicate all three at once. You can indicate, let's see if I can do it, something like that. So you can indicate all three kinds of motion separately and distinctly. So all of this is kind of, and so possible. The last element there of the sign language system, that's 11.2, I guess, it's the same thing, but it now stresses the other part of this. It's not just how many distinct categories can be indicated simultaneously within a single expression, but the fact that they're independent of each other, they can vary independently. They are not prepackaged into some languages' pre-selection of a nice schema for you to use. On the contrary, you make up the schema that you need on the spot to correspond to the actual physical characteristics. And so all these different things vary independently of each other. The rates at which something moves, the path it moves along, the figural shape, the manner, and so forth. You can vary all of them independently. So, to conclude, we've demonstrated that within this specific realm, namely structuring space, how language structures space, sign language and spoken language do it quite differently. In fact, I would say radically different. And yet they're both languages, full-blown languages done by the human brain. So it demands a reconsideration of theories about the language, so-called language module of the human brain. It can't be identical. It can't be a single language module as described by Fodor and Chomsky if you've got two full-blown languages, both done by humans, which behave so differently in their very, not just structure, but mode of operation. And what I propose is that instead of a full-blown language module, a language organ, I propose a much smaller language system, provisionally, even that could disappear, but let's say a smaller language system which accounts for those characteristics which are in common to both spoken and sign language. And I list in the end of the handout all sorts of properties that are in common to both spoken and sign language. But that, in turn, so this is the more modest language system, and in turn, it, as I said in the beginning, interacts with a visual processing, a visual structuring system also in the brain, so that together, this system constitutes the language system for sign language, and it seems to interact with another system for spoken language. What is this other system? That's the system that is used for prepackaging and modulation of those packets. So deformation and extension of those packets. That's the system that I outlined for spoken language. Well, why does such a system have, remember, language was the last, or that and culture were the last two cognitive systems to have evolved. Other cognitive systems were already in place. Why would this one already have been in place? Maybe it was used for the motor system. It may be that there exist in the motor system notions of pre-packeting rudimentary or fundamental motor components. So a motor component might be lifting one leg, bending at the waist. So, well, it turns out you need if you combine certain set of motor components, you get an action of sitting down. Well, maybe that's a kind of pre-packeting. Furthermore, you need to modulate the pre-packeting for different circumstances. If you sit on a ledge, it's very different from sitting on a stump, or on a fence. You modify the basic pattern for different circumstances. So maybe there had already evolved something like this packing and modulation system, and therefore it was ready to go to be co-opted by the language system. These are all really speculative ideas, but that's the direction I'm going in. And all of this looks more like what neuroscience is currently finding, that any kind of coherent behavior that one would typically identify as a single thing seems to be underlain by a number of different brain components interacting. So that's sort of what this kind of system looks like. And in turn, what I call the core line might itself resolve into smaller components, used themselves for lots of other things as well. Okay.